Lesson 70, Solving Inequalities by Multiplying or Dividing. Remember, just the other day we practiced solving inequalities by adding or subtracting. We're going to do very similar things whenever we solve by multiplying or dividing, with one exceptional rule that we must always remember. So, let's get started. When multiplying or dividing an inequality by a positive number, the sign does not change. Okay? So as long as what you're multiplying or dividing by is a positive, your sign is not going to change at all. And by sign, we mean the inequality sign. So for example, on this one, they multiplied by 3 on both sides. So 2 times 3 was 6, 5 times 3 was 15. 6 is still less than 15, just as 2 was less than 5. So my sign is the same all the way through. If I divide by the same thing, I'm going to divide by 3 is what they're showing. So 2 is less than or equal to 5. 2/3 is still less than or equal to 5/3. Okay? So it says, solve graph and check the solution for the inequality. If I have 1/3 x is greater than or equal to 2, I can solve this one of two ways. I can do it as a fraction and know that when I have 1/3 times x, that's the same as multiplying by its reciprocal. Okay, so I do that on both sides. So 3's, 1's cancel. I'm left with x is greater than or equal to, because I multiplied by a positive, my sign stays the exact same. It's very important that I work everything straight down so I don't make any mistakes. And then I have 2 times 3 over 1, which is 6. So I'm going to put 6 here. We'll put 7, 8, 5, and 4. My point at 6, okay, that's the number I'm talking about. I have the equal sign, remember, so that means it's going to be close. And then I can look at the sign to determine where my arrow should be shaded. And if I make that sign into an arrow, it points to the right, which means that I need to shade to the right. Okay? It wanted me to check my answer. If I check my answer, let's say I plug in 9 for x. So I would have 1/3 instead of x, I'm going to put 9, and that should be greater than or equal to 2. So if I have 9 over 1, it gives me 9 over 3, which is 3, which is greater than or equal to 2. So it works. The other way, which is what I was going to tell you, you could also recognize that this is the same as saying x over 3 is greater than or equal to 2. And you can multiply by 3. Everything is solved exactly the same way. It's just all about, whoops, it's all about how you write it. Okay? Both are acceptable. Whoops, whoa, whoa, whoa. Okay, example 2, same thing. It says solve graph and check the solution for the inequality. I want to get x by itself. 7 is being multiplied by x, so the opposite is to divide by 7, so I can move it. Do that to both sides, and then I'm left with 3 is greater than x. Now, whenever I graph this, I always want to graph when my variable's on the left side. So since my variable's on the right side right now, I'm going to flip the whole thing. So I'm going to move the variable to the left. I'm going to make sure that, see, it's pointing at the x. My sign should still be pointing at the x, so my sign flipped. And then my 3 is going to be on the right. So now, since I have my variable on the left side, I can go ahead and graph this. The point I'm talking about is 3. And I have 2, 1, 4, and 5. I'm going to put my point at 3. I don't have an equal sign, so it's going to be an open point because it doesn't include 3. And I'm shading to the left. So that is my final answer. Now I can check this by plugging in something that matches this. Now if I plug in 3, 3 is not included. If I plug in 3, I would get 7 times 3, which is 21. And 21 is not less than 21. It's equal to it. So that one, that's why that's open. It doesn't include it. So I need to pick something over here. So I'm going to choose 1. So if I had 21 is greater than 7 times 1, 21 would then have to be greater than 7, and that's true. It checks. When multiplying or dividing by a negative number, the sign changes. Okay? So, if I had this 2 is less than 5, and I multiplied by a negative 3 on both sides, I would get negative 6 and negative 15. But when I multiply by that negative, the sign has to change because negative 6 is greater than 15. Because when I graph those on a number line, negative 6 would be on this side of negative 15. Negatives, as the numbers, the absolute value gets bigger, the value gets smaller, right? So this is showing you why the sign flips. The same is true on this example. It says solve, graph, and check the solution for the inequality. So I have negative x over 2 is less than 7. I would guess that you would tell me to solve this by multiplying by 2 on both sides. And I have negative x is less than 7 times 2 is 14. There is a negative here, but I haven't multiplied or divided by a negative yet. So my sign has stayed the same. Okay? Now, to get rid of this negative, I know that this is negative 1x, so I'm going to divide by negative 1 on both sides. Cancels. I'm left with x. Because I divided by a negative, my sign has to change. So I'm going to flip it the other way. Instead of less than, it's greater than. 14 divided by negative 1 gives me negative 14. So I'm going to graph that. Negative 14 I'm going to put here. Negative 12, negative 16. And my point I know is going to be at negative 14. And if I make my sign into an arrow, I see it shades to the right. So I'm going to shade to the right. I didn't shade in my point because I didn't have an equal to, so it stayed open. Now I need to check my answer, so I need to choose something that works for this. So I'm going to choose negative 12 because it's on that shaded line, so it should be a solution. So if I put in negative, instead of x, I put negative 12, and then I'm going to take over 2. So all I've done is substitute negative 12. Notice I have this negative still here. Okay, x is equal to negative 12, or I'm using negative 12 for x. This sign still has to be there. So I'm just plugging into this original equation right here, or this original inequality. This is going to have to be less than 7. So negative negative gives me a positive. So 12 divided by 2 is 6, and 6 is less than 7. So it checks. Solve, graph, and check the solution for the inequality. So same thing here. I have negative 5x is less than or equal to 30. To get x by itself, I know that these are being multiplied. The opposite is going to be to divide by negative 5. So I'm left with x. When I divide by that negative, the sign has to change. So I'm going to change my sign to greater than or equal to. 30 divided by negative 5 gives me negative 6. So I'm now going to graph it. Negative 6. Put these other points on here. My negative 6, I know my point is at negative 6. I have an equal sign, so I have to shade it in. Okay, if I change my sign into an arrow, it points to the right, so I'm going to shade to the right. Okay, now I need to choose something to check with, so I'm just going to choose this negative 4. So I'm going to plug into the original inequality. I have negative 5 times a negative 4 must be less than or equal to 30. Negative 5 times negative 4 gives me 20, and 20 is less than 30. So that checks. A real estate agent receives a commission of 3% for every house sold. What price must a home be sold at in order for the agent to earn at least $6,000? Okay, so they earn 3% for every house sold. Okay, so they want to know the price of the home. Okay, they're getting 3% of the price of the home. 3% of, that means I'm going to multiply. So it's going to be 3%, and I'm going to multiply by the price of the home. And I need that to be at least $6,000. So, can it be less than $6,000? No, because it has to be at least, at a minimum. That means it needs to be more than, or it could be equal to, the least amount. It could be equal to 6,000. So then I just need to write this in equation form, or in inequality form. I am going to change my 3% to a decimal, so I have 0.03. And instead of saying times the price, I'm just going to put P has to be greater than or equal to 6,000. That's my final answer. So that's all I have for you today. I hope that you've taken good notes, and I will see you in class tomorrow. Have a good night.